Hi friends, welcome to all. In this video, we are going to see the packet tracer activity skills integration challenge. We will go through the background here. In this skill integration challenge, your focus is OSPFv2 and OSPFv3 configurations, right? So we will configure IP addressing for all devices. Then we will configure OSPFv2 routing for the IPv4 portion of the network and OSPFv3 routing for the IPv6 portion of the network. One router will be configured with both IPv4 and IPv6 configurations. Finally, we will verify our configurations and test connectivity between end devices. They given a note here. This activity is graded using a combination of assessment items and connectivity tests. The instructions window will not show your score, right? To see your score, click check results, assessment items. To see the results of a specific connectivity test, click check results and connectivity tests. Right. Anyway, this is at the end of the this packet tracer activity. We will come to the requirements. Use the following requirements to configure RA addressing and OSPFv2 routing. IPv4 addressing according to the addressing table. Process ID should be 1. Router ID 1.1.1.1. Network address for each interface. LAN interface set to passive. Do not use the default keyword. Coming to the topology, here we can see the routers RA, RB and RC. So just now we have seen the requirements of this router RA. Before going to this RA router configuration, we will check the IP address details from our addressing table. Here we can see the two interfaces. Yes, for RA we got only two interfaces connected. So the address for the gigabit Ethernet 0/0 is 172.31.0.1, and here we can see the subnet to mask 255.255.254.0, and here is the interface serial 0/0/0. The IP address is 172.31.4.1. and subnet to mask is 255.255.255.252. So we are going to configure this address on this device array. Coming to the router array, enable. So first of all we will configure the IP address, configure terminal. We will go to the interface gigabit Ethernet 0/0, and we will set the IP address 172.31.0.1, and the subnet to mask is 255.255.254.0. right. So we will give no shut command. Now we will go to the interface serial 0/0/0. Interface serial 0/0/0, and we will set the IP address 172.31.4.1, and the subnet to mask is 255.255.255.252, and we will give no shut command. Right. Now we are going to enable OSPFv2 as per the requirements. Right. Configure terminal, router OSPF, and the process ID is 1. Router ID 1.1.1.1. Also we have to set the passive interface, that is gigabit Ethernet 0/0, and we are going to specify the network 172.31.0.0, and the wildcard bits 0.0.1.255, and we have to specify the area 0, and the next network 172.31.4.0, and the wildcard bits 0.0.0.3, and the area 0. Coming to the next requirements, use the following requirements to configure RB router addressing, OSPFv2 routing and OSPFv3 routing. Right, IPv4 and IPv6 addressing according to the addressing table. Set the gigabit Ethernet 0/0 link local address to FE80:1. OSPFv2 routing requirements. Process ID should be 1. Router ID should be 2.2.2.2. Network address for each interface, right? LAN interface set to passive. Do not use the default keyword. Also, OSPFv3 routing requirements. Enable IPv6 routing. Process ID should be 1. Router ID 2.2.2.2 and enable OSPFv3 on each interface. So before coming to this RB router configuration, we will check the address of each interface in our addressing table. Here we can see gigabit Ethernet 0/0 IPv6 address. Here it is. And serial 0/0/0 IPv4 address. Here we can see with subnet to mask. And for the interface serial 0/0/1 IPv6 address is here. Coming to the router RB. Enable, so first we are going to enable IPv6 unicast routing. IPv6, we have to go to configure terminal IPv6 unicast routing. We will set IP address for the interface gigabit Ethernet 0/0. The IP address 172.31.2.1 and the subnet to mask is 255.255.254.0 and we will give no short command. Coming to our addressing table, here we can see the interface gigabit Ethernet 0/0 on the device RB. We have to set IPv4 address as well as IPv6 address. We already set this IPv4 address. Now we are going to set this IPv6 address. Coming to IPv6 address configuration on the same interface. So IPv6 address, here is our address. That's 2001:1:1:1/64. Also, we have to set the link local as per our requirements. So IPv6 address FE80:1 as a link local. Right, here we are going to give IPv6 OSPF1 area 0. Now we will configure the interface serial 0/0/1. No IP address. We are going to set the IPv6 address. Here it is. 2001:GB8:2:1/64. Also, we are going to give IPv6 OSPF process ID is 1 and area 0. Also, we have to give no shut command. Now we will configure the interface serial 0/0/0. Interface serial 0/0/0 and the IP address, here it is. 172.31.4.2 and the subnet to mask is 255.255.255.252. Also, we have to give the no shut command. Now we will configure OSPFv2. Router OSPF process ID should be 1 and router ID 2.2.2.2. And we have to set the passive interface gigabit Ethernet 0/0 and now we will specify the networks 172.31.2.0 and the wildcard bits 0.0.0 1.255 and the area is 0. The next network is 172.31.4.0 and the wildcard bits 0.0.0.3, area 0. Now we will set OSPFv3. We have IPv6 router OSPF1 and router ID 2.2.2.2. Also we will give clear IPv6 OSPF process. Yes. Next is use the following requirements to configure RC addressing and OSPFv3 routing. IPv6 addressing according to the addressing table. Set the gigabit Ethernet 0/0 link local address to FE80:3. Also OSPFv3 routing requirements. Enable IPv6 routing. Process ID should be 1. Router ID should be 3.3.3.3. and enable OSPFv3 on each interface. Here is our router RC. So before that we will check the addressing table. Here we can see the details of RC. Gigabit Ethernet 0/0. Here we can see the IPv6 address. Also for the interface serial 0/0/0. Here we can see the IPv6 address. Coming to RC. Enable configure terminal, and now we will enable IPv6 unicast routing. Now we will go to the interface Gigabit Ethernet 0/0. And we will set the IPv6 address. So we will copy that address from our addressing table. Here we can see that. Yes, here it is. Also we will set the link local IPv6 address FE80:3 link local. Right, now we will give IPv6 OSPF1 area 0. Also we are going to give a no-shut command. Now we will go to the interface serial 0/0/0 and we will set the IPv6 address. No IP address, and we have to set the IPv6 address. Already copied that address. Here it is. Also IPv6 OSPF1 area 0, and we have to give no-shut command. Right, now we are going to configure OSPFv3. So IPv6 router OSPF process ID is 1 and router ID 3.3.3.3. Also we have to clear IPv6 OSPF process. Yes. Next is configure PCs with appropriate addressing. PCA and PCB IPv4 addressing must use the last assignable address in the IPv4 subnet. PCB and PCC IPv6 addressing must use the second assignable address in the IPv6 network and the link local FE80 address as the default gateway. Finish the addressing table documentation. Coming to the topology, here we can see our PCA and PCB. For the PCA, we are going to assign the last usable IP address from the subnet, and for the PCB, we are going to assign the last usable IP address from this subnet. Here we can see in this network the IPv4 address is 172.31.0.0/23, and in this network the IPv4 address is 172.31.2.0/23. Coming to our spreadsheet, here we can see the first address 172.31.0.0/23. Here we can see the CIDR is /23. So I given here the binary for this address. Here we can see that. Also, the first 23 bits are belongs to network portion. So I highlighted and made in red color. Here we can see that. Remaining 9 bits are belongs to host portion. So I put all the 9 bits zeros. So I got here the start address of this subnet. Also, here we can see the same address with the 23 bits belongs to the network portion and 9 bits belongs to the host portion. So the host portion I put all the ones, and here I got the last address in this subnet. So here we can see the start address and end address. So for our PC, I mean here we can see the PCA, we have to assign the last usable IP address. So here we can see the broadcast address 172.31.1.255. So obviously the last usable IP address in this subnet is 172.31.1.254. Obviously it's one less than the broadcast address. So we will add this address in our addressing table in our spreadsheet, that is 172.31. It's 1.254, and the prefix obviously it's a /23, that is a 255.255.254.0, and we have default gateway. Here we can see that the IP address of this interface gigabit Ethernet 0/0 on the router RA, that is 172.31.0.1. Coming to PCB IP address, the last usable IP address from this subnet. Here we can see that in our spreadsheet. It's 172.31.2.0/23. I made the binary of this address, so here we can see that. So in this, the first 23 bits are belongs to network portion. Here we can see that, and remaining 9 bits are belongs to host portion. So all these 9 bits I put zeros, and I got the first address in this subnet. Also here we can see for finding the last address of the subnet, the host portion put all the ones. So here we get the the broadcast address of this subnet, that is 172.31.3.255/23. So obviously for the PCB, the last usable IP address will be one less than this broadcast address, that is 172.31.3.254/23. We are going to fill these informations into our spreadsheet. For the PCB, it's 254, 172.31.3.254, and subnet to mask, here it is. Also the default gateway 172.31.2.1. Next is IPv6 address for these PCs, PCB and PCC. Coming to our addressing table, here we can see in this router RB, the interface gigabit Ethernet 0/0, the address given is 2001:DB8:1:1/64. So as specified in our requirements, we have to use the next usable address. So here we can see 1:2/64 can be assigned to this PCB. And coming to PCC, the router RC, the interface gigabit Ethernet 0/0 uses 2001:DB8:3:1/64, so that we can assign to this PC 3:2/64. We will add this information into our spreadsheet. So this is for PCB. We have to use here 1:2. Also the default gateway as FE80:1. Coming to PCC, here we can see that gigabit Ethernet 0/0 address. I am going to copy this so that we can edit that. It's 3:2. Also the default gateway FE80:3. We are going to set the IP address for these NT devices. First we will set the IPv4 address for PCA. So just we will copy from our spreadsheet. Coming to PCA, IP configuration. Right, and we have to change the subnet to mask to 55.255.254.0. Also we have to change our default gateway. It's 172.31.0.1. Right, now we will go to PCB. We will copy the IP address. Right, not copied. I will copy once more. Right, coming to PCB, and subnet to mask is 255.255.254.0, and we have to change the default gateway 172.31.2.1. Also we will set IPv6 address for PCB. So here is our address. Here 64, and here we can see the link local address. Also we have to set the IPv6 gateway, that is FE80:1. Right, so now we will come to PCC desktop IP configuration. So we will copy the address from our spreadsheet for the PCC. Right, link local address as it is. Okay, we have to set the prefix length here 64, and coming to IPv6 gateway, it's FE80:3. Next is verify your configurations and test connectivity. OSPF neighbors should be established and routing tables should be complete. Pings between PCA and PCB should be successful. Pings between PCB and PCC should be successful. So they given a note here: if OSPFv3 has not converged, check the status of interfaces using the show IP OSPF interface command. Sometimes the OSPFv3 process needs to delete it from the configuration and to reapply to force convergence. Right, so now we will verify our configurations one by one. Coming to RA, show IP OSPF neighbor, and here we can see the details. Also we will check the routing table, show IP route, and here we can see the path learned using the protocol OSPF. Now we will come to RB, show IP OSPF neighbor. Yes, here we can see the details. Also we can check show IPv6 OSPF neighbor. Yes, here we can see that. We will check the IPv4 route, show IP route, and here we can see the path. Also we will give show IPv6 route, and here we can see the route. Now we will come to the router RC. Show IPv6 OSPF neighbor. Here we can see the details. And coming to the routing table, show IPv6 route. Yes, here we can see that. Now we are going to ping from PCA to PCB. So we will get the IP address of a PCB. Here is the address. So we will ping from PCA. Command prompt ping to PCB. Yes, we are getting the reply. Now we will ping from PCB to PCC. We will get the IP address of this PCC. Here is the address, IPv6 address. Coming to PCB, command prompt. Here we are going to ping to PCC. Yes, we are getting the reply. Now we will check the results. Assessment items. So here we can see everything done well. Also here we can see connectivity test, total 58 out of 58. We can see here connectivity test 29 plus 29. Yes, it's 58. Yes, that's all in this packet tracer activity. That is a skills integration challenge. Friends, if you have any doubt in this packet tracer activity, please comment below. Also, if you like my video, give a thumb. And don't forget to subscribe the channel so that you will get latest uploading video info into your Gmail. Thank you.